Good morning, everyone. Welcome to this session on practical techniques for applying data quality in Databricks Lakehouse. My name is Li Ping. I'm a senior solution architect based out of UK. I specialize in data engineering, data warehousing, business intelligence. This is my coworker, Lara.
So hi, everyone. I'm a solutions architect, also based in the UK, working with Li Ping, and I specialize in data governance and Gen AI.
Right, so this is today's agenda. You'll notice that we're not talking to you about why data quality is important. You already know that, otherwise you wouldn't choose to spend your first session of Summit with us, so thank you very much for that. We'll start with the 6 dimensions of data quality, what makes good data, and then we'll talk about the data quality lifecycle management. We'll discover different techniques available to you based on the different maturity level you have currently in implementing your data quality strategy. And last but not least, we'll cover an example medallion architecture and show you where in medallion architecture you can apply different techniques that's available to you in Databricks. So first, what makes good data? What does data quality means? In this presentation and in the data quality guide that us two wrote for Databricks.com, the 6 dimensions of data quality consist of consistency. This consistency has nothing to do with the ACID compliance of Delta. This consistency means that the data points, the data values in different tables or different data sets should not conflict with one another. So you have single source of truth. Accuracy. Accuracy means the data in your data platform should reflect the reality of your business. There shouldn't be any errors in the data that you're presenting to the business. Validity. Validity means based on your business requirement, industry requirement, and potentially compliance requirements, data should conform to certain formats. Completeness. You don't just want the truth about your business, you want the whole truth about your business. That means there shouldn't be any missing data in your data set. Uniqueness. Duplicates are very dangerous, especially when you're running aggregations on your data. If you have duplicates in your data, your aggregations can be inaccurate. That's why your data should be unique. Timeliness. Depending on your business requirements, most of the business want to have the most up-to-date picture of their business. And these 6 dimensions are what we're going to discuss about data quality, and we'll go through the native Databricks features available to you to address these 6 dimensions. Now, we want to talk about data quality management lifecycle. You start with discovery. Discovery means you talk to your business, you talk to your regulators, you understand what their expectation is, what their requirement is for data quality. And you want to do some data profiling after that. Data profiling will help you identify the trends and the patterns and anomalies and outliers of your data. Together with discovery and data profiling, you can set some rules for data quality. These rules address the 6 dimensions we just talked about. And once you set the rules, detect the data that violates those rules, you want to do some cleansing and standardization, address those issues. Throughout this process, you want to monitor and do the reporting of your data quality metrics. Report back to the stakeholders when they said, I have this and this requirement, I expect this and this in accuracy, completeness. You want to report back on how your data pipeline is doing based on what the expectation and the requirement is. Now, everybody, when you first start with data quality, the first thing you think about is, I want to identify some issues and cleanse some data, meet business requirements. This is why in the crawl stage, you want to do discovery, you want to do rule setting, and you want to do cleansing and standardization. Discovery is not a technology problem, or not just a technology problem. This is actually more of a people and a process problem in addition to technology. You will want to talk to people in your business who are producing the data, who are using the data, consuming the data, governing the data. You want to understand what their expectation is when it comes to use your data, audit your data, and so on and so forth. And you can run different techniques when it comes to requirement gathering. You can do interviews, surveys, requirements, workshops, observations on how people are using data today, and then do an assessment of your current data quality status, identify area of improvement for new implementation of data quality strategy. Coming from that, you can do some rule setting. The first, you want to set the rules that meet business requirements. And then you want to do some rules that's semantic layer. So think about things that make sense for the universe. Things like heartbeat shouldn't be less than 0. Things like distance between 2 points shouldn't be less than 0. And then if you operate in an industry where you're exchanging data with other entities, you might have some interoperability rules that data have to conform to certain formats. And also, if you're operating in a regulatory industry, you might have compliance rules you have to set for your data quality. All of these together dictates the requirements you will set for different dimensions across data quality. Now, let's get started with inconsistency. Different things can cause inconsistency to happen in your data set. You could have the same data points vary in different sources. You can have an inconsistent transformation logic or imputation technique that results in inconsistency in the gold layer. Or you can have a varying definition of a business metric. For instance, if different teams define profits in different ways, you might have inconsistencies in gold layer. The techniques to address these inconsistencies is merge. So merge when not matched insert is a great technique to identify duplications. But you can also use that for identifying inconsistencies. Join is a good one as well, depending on your data type you're trying to identify inconsistencies in. You can join two tables together and do inconsistency checks from there. Inaccuracy. So delta life tables give you the capability out of box to do expectations. You can set rules for data quality, expect your data to fall in certain ranges, and with delta life tables, you can set actions based on your violations of those rules. With constraints of delta tables, you can also identify inconsistencies and deal with it. You want to be careful with that because with constraint, both not null and check. Check means you can check for Boolean expression whether data is meeting that expression or not. When you're using constraints, if any row in the data set is failing the constraint, your entire operation will fail. So roll back to the previous state, and you will need to address the data quality issues before writing into that table. Constraints also have a property where you cannot add constraints to a table or to a column if that column has data that's violating these constraints. For instance, you can't write not null or you can't add not null as a constraint to a column if that column already have no values in it. So you want to either set constraints before you load the data or potentially clean up the data before you add any constraints in. Copy into. Validate in copy into give you the ability to check the data schema, to check the not null before you write or before you ingest into a table. But you want to also potentially set the number of rules that validate is checking. Otherwise, it will, by default, check the entire data set. Now, once you identify inconsistencies and inaccuracies, you want to handle those violations. First action you can do is to drop the records. Again, with Delta live tables, you can just set on violation drop records. All the dropped records, all of your data quality metrics is automatically logged in event logs, and you can query it using DB SQL afterwards. The second thing you can do with Apache Spark is to do a filter. You can filter out the values that failed your data quality checks. If you don't want to drop the records, if you want to keep the records for later processing, you can potentially quarantine the data. Quarantine the data typically happen in two different stages. Either you do it during ingestion, or you can potentially do it during data processing. In ingestion, you can utilize something called bad record path. Basically, Apache Spark will write bad records and bad files into the path that you specify, or use autoloader. So autoloader by default will write any data record that doesn't meet your schema into a rescue data column. During data processing, you can use Delta live tables. If you write an inverse version of the expectations, you can send those records and write it into a quarantine table. In the future, Delta live tables will give you the capability to quarantine data out of box. With Apache Spark, again, you can use an inverse version of filter and write whatever is violating your data quality checks into a separate table if you want to. Schema enforcement is important because you want your schema to conform to a certain format. Delta, out of box, gave you the capability to do schema enforcement. That means anything that's writing to Delta, if you don't specific set Delta schema evolution, Delta will fail the operation of write. With autoloader, it also does schema enforcement. It will write anything that doesn't comply to the schema into the rescue data column. But today's world, a lot of people are ingesting data from different APIs, NoSQL database, which means your schema can evolve over time. So Databricks also give you the capability to do schema evolution. You can set merge schema options to be true on Delta, and then what Delta will do is it will add additional data columns for you. Or you can set auto merge on a single Spark session and utilize the schema evolution from there. You can set schema evolution for autoloader as well. But these schema evolution techniques will give you the capability to add a data column, but it doesn't address things like if you delete a data column, if you change the type of a data column. That is not what schema evolution is trying to address. If you want to do things like that, you potentially want to do a schema overwrite. Again, overwrite schema option to be true is a property of Delta. If you set that to be true, Delta will rewrite the schema of the table. You want to be careful with that, especially if your Delta table is big. You don't want to rewrite your table all the time. Alternatively, you can also manually update the schema. Databricks give you all of these capabilities to manually update your schema based on your requirements. With completeness, there are different techniques available to you. You can use Spark to impute the missing data. These are just the common techniques. Or if you're using like AutoML within Databricks, you can choose your imputation methodology in the process of setting up your AutoML experiments, and AutoML will automatically do the imputation for you as part of the experiments. Drop duplicates. Databricks give you 4 different capabilities to do drop duplicates. You can do the merge when not matched insert. That's a great deduplication opportunity. And then distinct in PySpark, that also works. With distinct, it will check the uniqueness for every single column. So if you want to check the uniqueness for set selective columns, you want to do a select first before you call the distinct method. Drop duplicates also works. Again, this is a method that will check all of your columns for uniqueness. If you want to do a dedupe on select columns, you want to pass those column names as configuration for drop duplicates. The previous three methods will keep the first record and drop the duplicates on all the following methods. If you have a situation where all of the incoming records, the latest arriving one is your version of truth, and you want to keep that one and drop all the duplicates before that, you can do something like ranking windows. It's more complicated than before the previous three methods, but that is used for addressing specific situations like the one we just described. With rollbacks and vacuum. So these are gatekeeping mechanisms. If you have accidentally wrote inaccurate record, you can roll back to the previous version. If you have a situation where you had inaccurate records in the history of the table and you want to prevent your users from reading those, you can do a vacuum of their delta table so that any data consumers cannot read the previous versions that might contain inaccurate data. Structured streaming, as well as delta live tables, give you the capability to process real-time data and serve it into something like Power BI, Tableau, or Databricks dashboards that produce the up-to-date insight from your data to your business. So both structured streaming and delta live tables will give you the capability to meet the timeliness requirements of your data quality. Now Lara's going to walk you through the walk and run phase of the data quality maturity cycle.
Great, so now to the walk stage of the life cycle. And here we're going to talk about first data profiling and then monitoring and reporting. So starting with data profiling, the goal of data profiling is to identify all the trends and the patterns in your data so that you can understand the data, but also spot outliers and anomalies. There are three techniques that you can leverage in order to do that. First, DB utils, so that you can do like summarize, your data frame and see some visualizations. But you can also actually just see that in the UI in your notebook as well with the data profile. But you can also leverage, if you want, pandas profiling Python library. So all those techniques can allow you to understand your data and understand, trends and patterns. And then an important dimension of data quality, an important thing is metadata management. With metadata management, one thing you need to think about is augmenting your data. Adding metadata, so context about your data, is very important to facilitate discovery in your organization, data discovery. For this, you have a number of techniques that you can leverage. First, you can augment your data with current timestamp and input file name. So current timestamp allows you to identify the timestamp when a query was done. So for example, the timestamp when records were created. And input file name allows you to put the name of the file that was read, for example, when creating a table. The reason it's important is that, as you can imagine, for auditing purposes, it's good to have the timestamp when the table was created, and then you can see also the relationship between the tables and the source files. And then you probably already know about those techniques. We can leverage table properties. It's like user-defined key-value pairs. So for example, contains PII equal true, but you can also just add comments to your tables and your columns. But in this room, who likes to spend time adding information, metadata, and documenting? I think no one likes to do that. It's one person. It's a thankless task to do, and nobody likes to do it. So the great news is that in Unity Catalog, you can not only add descriptions and comments all the way down to the column level, but by leveraging Databricks IQ, you can also have this generated for you. And then you can just either accept what was generated, reject it, modify it, And it's really important because tomorrow we're going to have great announcements about natural language querying in the Lakehouse. So stay tuned for this. And if you want that to work well, you need to have metadata and context about your data so that the AI layer can really understand what the data is and the context around it. And so now onto monitoring and reporting. And for this, we're going to discuss, of course, about Lakehouse monitoring. Now, I'm not going to deep dive into it because there's a dedicated session for this on Thursday. But in a nutshell, it's a capability that allows you to monitor your data and your machine learning models over time. And so you can just monitor delta tables by choosing 3 options, either time series or model inference for your machine learning models. Now, the way that it works is that when you have a machine learning model, you can have an inference table. So for example, you have a request that is made to a model. This request can be a record with a timestamp. Then you have the model input and the associated prediction. And that's what we monitor using Lakehouse monitoring. Snapshot is just a general category for all the other tables that are not time series or machine learning related. And as an option, you can even add a baseline table, which is basically what good looks like and the ground truth that you want to compare it against over time. And so when you do this, what's going to appear, I don't think the GIFs are appearing on the, okay, there was supposed to be a GIF here, basically that shows the dashboard that appears. You can see some automatically computed metrics in a fully customizable dashboard that looks a bit like this. And so in the dashboard, you can see some basic information about numeric data, about categorical data, and you can answer lots of questions such as, what is the fraction of nulls or 0 values in my dashboard? And what is the 90th percentile on this column? How is my model predictions evolving over time? Is it changing? But it doesn't just give you a dashboard. As you can see here, highlighted in yellow in the screenshot, you also get a profile metrics table and a drift metrics table, which are logged into Unity Catalog, and you can then build dashboards on top of that and alerts. So here, apologies, there was also a recording that doesn't appear, but basically you can also set up alerts. So if you go back to like the dashboard, on each chart, you can just click onto it, and then you can click onto see the underlying query, create an alert, and then based on the trigger condition, for example, if a certain threshold is met, then you get an alert. And of course, with delta life tables, as Liping mentioned, you can set up expectations. And those expectations, they're surfaced into this tab, this data quality tab, where you can see, for example, here you have one expectation that's called valid trip distance, and there's 22% of the records that are failing this expectation, and you can see that. But also, what's really interesting is that you can have all the event logs, which you can then surface in a dashboard using DB-SQL or a BI tool of your choice. And finally, also what's really interesting is that, of course, using Unity Catalog, you get data lineage out of the box. This is important for data quality because let's imagine that you have a machine learning model and you notice that there is a drift and that something is wrong. Maybe you want to automatically retrain the model, but maybe you want to do some root cause analysis because it could be that actually the problem comes from a bronze table where you have a bunch of nulls that appeared, out of nowhere, and that actually you don't need to retrain the model. It's more the bronze table that needs to be addressed. And thanks to lineage, you can explore all the relationships between the tables. And what we have here on the screenshot is something that is on the roadmap where we actually want to surface those data quality issues automatically for users so that they can proactively go and try and address that. Now the run phase of the life cycle. And that means we're going to discuss a bit about data ops, ML ops, and LLM ops. So why are we talking about CI/CD? Basically, This is important because human errors are really a hidden threat to data quality, because you need, like, manual processes are error prone, so you need to reduce manual processes as much as possible by automating as much as possible and by running tests consistently. And that's what CI/CD is about. And generally, the way your workflow is, it can vary from one company to the next. Sometimes there's no staging, sometimes there's more, but generally you have a dev, stage, prod approach. And as your data goes from one layer to the next, you expect that it meets higher and higher quality standards. So when you start in the dev environment, this is a sandbox where your data engineers, your data analysts can basically play with the data because they're in a controlled environment where they're not going to break everything that is in production. It's isolated. And one thing that's important from a CI/CD perspective is that you need to encourage data engineers that they need to run tests, because before you promote whatever is built to staging, they're going to do a pull request so that their peers can review what they built. And nobody wants to look silly by having a peer reviewing something that doesn't work, which is why you should run some unit tests. And so when it passes those tests, you can then promote it to staging. Staging, this is the environment that tries to mirror whatever happens in the production stage. Because when you do unit tests, you basically test in an isolated way blocks of code and data pipelines. But then you want to make sure that when everything is brought together and when it integrates the wider system, that it actually runs well. So that's what we call integration testing. Then you hand over to probably your operations team, and that's when you're ready to do what we call deployment into the production environment. So production environment, that's the highest level. That's where for example, you have your goal tables where the analysts are going to be able to query dashboards in a live manner, where your machine learning models are going to do predictions in real time. So you want to make sure that everything runs smoothly. And secondly, even after it reaches this point, you want to make sure that you have ongoing monitoring to ensure that the data quality stays high. And any data issue needs to be fed back into the DataOps lifecycle. And that's what CI/CD is about. CI is about continuous integration, meaning we run unit tests, we run integration tests, and we try to do that in an automated way. And then continuous deployment or delivery is the way that we automate deploying that to the production environment. What are the tools that you can leverage in Databricks in order to do that? First, you need some kind of source control, such as Git. For this, you can leverage repos in Databricks, which is now just renamed to Git, actually, which makes it simpler. You can also leverage Databricks Asset Bundles, which is our CI/CD capability inside Databricks. Terraform is fully supported on Databricks, and I highly encourage that once you reach this run stage, that you really put everything to Terraform to automate as much as possible. And of course, Lakehouse monitoring that we discussed in order to monitor the quality over time. Now, what are the differences when we talk about ML? Actually, it's still quite similar from a CI/CD perspective. It's just that you're going to have some specificities compared to data ops. You want your model to also progress through those quality thresholds. And when it reaches prod, that's because it's at a stage where you're confident that the predictions it's going to make are of high quality. So here, the data scientists are going to play with the data, and they're in a controlled environment. They're going to select certain algorithms, train their model, and here, what's really important is that they make sure that they track everything by using MLflow. You need to track the data that the model was trained on. You need to track the features that were used. You need to track all the artifacts for all the various experiments that you do so that you can have some sort of reproducibility. And so everything, everything needs to be tracked with MLflow. Then you're still going to have some sort of tests. And so here the only difference is that you can do some API level tests when you want to mimic the prod environment where the machine learning model is going to be live. And here, before you promote it to the highest stage, within MLflow, we have what we call the model registry. It means I decide that this model is the best one, this version is the best one. Let's promote it to the model registry. This is the model that we're now going to deploy into prod. And so once it's in prod, you can do some real-time inference with model serving. You should monitor the model and retrain if required. So for this, use Lakehouse monitoring. And because you made sure to track everything using MLflow, you can always roll back to previous versions of the model if required. And the tools that you're going to use is the usual suspects that we just saw, repos, dabs, Terraform, Lakehouse monitoring. But of course, here, MLflow is crucial to machine learning. And now, LLM ops. So this follows the same. You need to make sure that your GenAI apps that you build are also of high quality, especially when they're customer-facing. You need to make sure that the output, that the responses that they make are of high quality. There are some specificities when it comes to large language models, is that first, it's not just about data, code, and the model itself. You're also going to build prompts, and you need to store them. And more likely than not, you're going to have several components that you need to chain together using a chain orchestrator like Llama Index or LangChain. What you can do in this dev environment is using MLflow again. MLflow allows you to do prompt iteration. It allows you to package the pipelines that you just built, where you can leverage one LLM and the next. You can track queries and responses. And here, in terms of quality, it's really important to enforce some guardrails. So for example, you may want to add a filtering system so that you can filter out toxic responses from your LLM. And that brings us to the evaluation part of the outputs. Right now, human feedback in 2024 still remains crucial when it comes to evaluating LLMs, meaning you need to have humans evaluating the quality. Why is that so? It's because you cannot use traditional metrics like precision or recall to evaluate text, for example. And so the problem is that this can be costly. This can be time-consuming. So what we recommend at Databricks for now is also using what we call LLM as a judge. LLM as a judge, it's a bit specific. So you have an LLM giving you a response. Let's imagine you have news articles that are summarized, and you could tell another LLM to evaluate those responses by giving you a score from 1 to 5. For example, 1 is bad, did not manage to identify the actors, the date, or the location right. 5 out of 5 managed to get all those box ticked. So that's a technique that you can use that can give you comparable, if not better, results than evaluating with humans. Then if the outputs are still of very low quality, you may want to move away from just prompt engineering and leverage what we call RAG, retrieval augmented generation, where you bring context to the LLM to make the answer more contextually correct, or even fine-tune your model. So imagine you want to build a chatbot that gives answers to patients, like medical questions. It's likely if you just leverage an LLM that's trained on the general internet that it's not going to give you the answers you want. So then you might want to fine-tune this LLM with medical data, for example, so that it gives you really good, precise answers. Then when you move to staging, again, make sure to use, enforce guardrails and still integrate human feedback. This time, because you try to mirror when it's going to be live, you can integrate live human feedback. So for example, if you have a chatbot, users can give a thumbs up or a thumbs down, depending on the quality of the response, and you can still use LLM as a judge. And then you reach prod, and so here you can deploy your LLM pipelines. that are packaged using MLflow. You can do real-time inference using ML model serving or AI gateway for external models. Make sure to track queries and responses using system tables. And again, human feedback and guardrails are key to guarantee the quality of the outputs when you build Gen AI. And the tools here, apart from MLflow that we already saw, Llama Index and LangChain when it comes to chain orchestrators, Hugging Face can be used as a model repository. And if you're feeling very adventurous, you can even do automated prompt development using DSPy. Putting it all together, so here we try to look at all the techniques we just went through, which was a lot, and just look at where they should be leveraged in the medallion architecture. So looking at bronze, silver, gold. So when you detect inconsistencies, that should be done at all the levels, making sure, of course, that in the bronze layer, you limit yourself to detecting that, but not dropping inaccurate data. So handling violations, that should be done preferably at the silver and the gold layer. We still added autoloader here because sometimes you may want to quarantine bad data. We've seen those examples in customers, but ideally you want to handle that at the silver and gold layer. Schema management, being presented on this. Delta is your best friend for this, but also autoloader at the bronze layer for schema hints, etc. When it comes to imputing missing data, we put it both for silver and gold because obviously the rules may differ at the silver layer and the gold layer, depending on the data consumers of those tables. So here, those are the techniques that were presented. But when it comes to removing duplicate records, though, we think like this should also only be at the silver layer. Bronze layer is the source of truth. You only remove that at silver layer. If you identify duplicates at the gold layer, this means you need to go back to your drawing board and make sure that you remove those duplicates because this means you do not have a single source of truth. And then all the other techniques can be leveraged at all the layers when it comes to enabling rollbacks, but also profiling the data, augmenting the data, monitoring and alerting, and then also lineage obviously is at the 3 layers along with your CI/CD pipeline.
Right, so it's a 40-minute presentation. If you remember anything from the last 40 minutes, we want you to remember these 3 things. 1, data quality is the foundation of everything. You can do BI, you can do AI, you can do LLM, you can do traditional machine learning and data science. Without proper quality data as the foundation, the data insights you produced will be inaccurate and inappropriate for your business decision makers to drive the business strategy from. Your LLM models or your machine learning models will be imperformant. So get the foundation right. Do data quality as the crawl, run, and crawl, walk, and run that we went through. We didn't show you any code snippets in this presentation because the 2 of us wrote a data quality management guide with Databricks. If you just Google data quality management with Databricks, that should be one of the first results that came up that has all the code snippets and a lot of the techniques that we went through today in the presentation. So before buying any of the fancy partners or solutions that you might see out there, start with the basic features that Databricks already offer out of the box from Delta, from Spark, from Delta Live Tables, from Lakehouse monitoring. Start from that and see if that meets your requirement and then go beyond that if you need to. And this presentation went through the data quality lifecycle management. We want you to start with requirements. Any of the rule setting, any of the cleansing cannot appear without proper investigation of your business requirement. So start with a requirement, work towards automation. If it's not automated, it's not properly built. It cannot be repeated over and again, so you want to start with requirement and with automation and iterate through. Data quality is not a static concept. Your business requirements will evolve, your industry requirement will evolve, your compliance requirement will evolve. So you want to iterate through that process and go back to your business, validate your data quality metrics, and gather additional requirements if you need to. I think that's the end of the presentation. Because it's the first session of the summit, you have a whole lot of other content within the summit this week. You can go and check out other sessions around data quality if you're interested. Thank you very much. We ran out of time, but you can come to the stage and ask us any questions.